Third example, Gabby is going to come up and apologize for her comment from last hour. She is shaking her head no. Wow. Okay, I am going to draw the tangent graph for you. Okay, we'll go up 3, go back 3, and one at 90, at 180, at 270, at 360, and I'm going to go back to negative 90. All right, so if I am drawing, is it still 2, 2? Or to us. I am going to draw this for you. How about when I test you on Wednesday, will I draw this for you? I mean, I will be drawn on the test for you. Yes. So you don't need to know how the tan graph goes. So the tan graph has, and we're recording this, so I have to be real careful when I say it. Asymptotes. Okay, all right, they probably didn't hear it. Okay. A little dotted line coming up and down at 90. A dotted line coming up and down at positive 90. A dotted line coming down at 270. And now the graph itself, I'm going to put a point at 0, a point at 180. I could continue and put a point at 360. I could continue the other direction. All right. So I am going to give you the original tangent graph. Okay? I'm going to start with the easy ones. I'll give you a few seconds. The range is easy. Does it ever stop going down? Does it ever stop going up? All real numbers, undefined, all real numbers. I'll accept anything like that. So the range is pretty cool. Okay, let's see. The period. It is not 360 degrees. Does it repeat itself more often? In fact, what's 90 minus negative 90? Say 180. 270 minus 90 is? The period is 180, and you can get it just by looking at that. Okay? The amplitude is the highest number minus the lowest number. You can put undefined or no amplitude, because there is no highest number, no lowest number. There's various ways that math people do it. Okay, the tricky one, whoa, who knows what just happened there? The tricky one is the domain. And the tricky domain is the following. On all of the other sine and cosine, we are so very positive attitude. Our great positive attitude says x can be all the real numbers. Everyone can be in the domain. This domain becomes a more negative thing. And what we do is write x is not equal to, leave a little bit of room. This graph never gets to the asymptote of negative 90. It gets really close. It never gets there. Leave a little room and write negative 90. You can write degrees or not. It doesn't matter. This little dotted thing at 90, it never gets to. This little dot of asymptote, it doesn't get to. Would this pattern continue way out here? So we'll put a dot, dot, dot at the end of our domain. Does this pattern continue this way? It does, and we go dot, dot, dot. Okay. would you do the following? Turn your blank piece of paper over and draw this graph again on the top of the backside. Do I have enough time? Probably. Once you've redrawn that tangent, below it, would you write y equals tangent 2 theta and then don't do anything? Mr. Malky was brilliant, was he not? Is that inside? Do you double it? No, you cut it in half. All right. Let's look at some important points on the tangent graph. Let's look at some important points. Is 0 an important point where it goes through? Please cut it in half. Say, it's still 0. There is an important asymptote at 90. Please cut it in half. What's that? So you're going to add a second line at 45, which has an asymptote here. Let's look negatively. Negative 90. That's an important point. Please cut it in half. What do you get? Negative 45. $180 was an important point. Cut it in half and it is now 90. $270 was an important point. Cut it in half, that is 135. So these important points, we've cut them all in half. And if you look up here, please, here's what the graph looks like. It just almost gets to 45. It almost gets to 90. And it would continue on and on. The amplitude's the same. The range is the same. The period is not 180 degrees. The period is, someone said 90 degrees. And now, once again, the domain. Let's be negative people. X cannot equal, ... coming from the negatives. It can't be negative 45. It can't be 45. It can't be 135, and it goes on. Say, I think I get this. Good, let me save. Ooh, barely made it. These recordings can only go 10 minutes at a time. I know you'd love the math recordings to go much more than 10 minutes at a time.